And then in 2016, I took the office up into the mountains in Austria, and we met lumberjacks and cut down trees, and we went to the sawmills and went to a CLT factory, and then I got them all together and I said, I've got this idea, and expected them all to walk out, but anyway, got this idea that we're going to be 100% timber as a practice. That actually what we know and what we understand is if you're going to build with a new material, build with a completely different material, then you have to design in that material. You know, you have to think from first principles, what am I going to make it out of? You know, how will that affect or inform the design? So from 2016, we committed as a practice to design every building in the practice as though it's going to be built from timber. And we now have 6 timber buildings on site, 1 concrete one, and 23 timber buildings in the office in process. So last year we did this building here, and this really is urban housing, high density urban housing. When we got this brief, the planning brief for the site was 3 20-story towers. And we were able to demonstrate that actually by doing it in a kind of high density manner like this, that we were able to build 10 stories, 1 building across the site, rather than the towers. But that's a whole other subject about density and high rise and stuff. So that building would have weighed 10,000 tons in concrete, but in timber weighs less than 2,000 tons. So you can imagine the implications for deliveries and everything and being much lighter, foundations, etc. 7,000 tons of carbon dioxide stored in the body of this building. So this is kind of like, I probably should kind of wind back here, that if you imagine that a tree is this perfect carbon storing invention, that actually if you kind of, you know, if a scientist came to you looking for a way to store carbon, this actually is a natural phenomenon that soaks up carbon dioxide from the atmosphere, releases oxygen, provides ecosystems for wildlife, and is retained as a carbon store. So when we use the building material, when we use timber, these buildings, not only are they low carbon in terms of the amount of energy that they take to produce, but they are actually carbon stores themselves. So they're storing thousands of tons of CO2. And we're at this building about 200 years of storing carbon for current building regulations. So 121 homes, 4,000 square meters of business, 16,000 square meters, 10 stories, 34 meters tall. This is the lift shaft here. When we fitted our first timber lift shaft, the guys turned up to fit the lift shaft, and they saw the building was in timber, and they turned round and left the site. And we literally had one of our students like running down the road, chasing, and we stood in front of them and said, "Come back, please, please." And now we get a discount because actually the structure of these buildings doesn't move at all. It's completely true, completely accurate. And if you can imagine what it must be like to fit a lift inside a concrete lift shaft, you know, where you're fitting metal rails for the lift to run up and down, and you're inside that contained closed space with a hammer drill, drilling every meter to put in big bolts to screw this in, and the difference between that as a process and using a cordless screwdriver on a material that isn't plus or minus 30 millimeters, but is actually completely accurate and won't move. So we clad it in brick. That was so I sat, we weren't originally going to clad it in brick, and I brilliantly sat in one of those planning meetings where the planner said, with me and the planner and the client, and the planner said to me, "Have you thought about cladding it in brick?" And the client said, "Oh my God, I'd love it if you clad it in brick." And I'm sat there going, "I don't want to use brick. It's stupid." Anyway, so we have a brick building, which actually looks really pretty, but you know, the thing about using, and is very contextual, and demonstrates as well that we can use this building material with really any kind of form of architecture. We can contextualize this kind of building, you know, be it in stone or be it in brick or whatever, but preferably in a lightweight cladding, because about 10% of the timber in this building just holds up brickwork. So 800 people live in this building. It took 2,325 trees to make the building, so that's less than 3 trees per person for the building, which I think is okay, right? And that's about the same in terms of the paper that everyone uses a year in terms of the amount of tree fibre. So this is the building here. You see going up here, 10 stories. in timber with the windows, etc. And you can see here finished. By the time the train's gone past, we've finished. So fast.